Hey folks, I'm back. Wow, we only have half an hour remaining. Time goes fast if you're having fun. So, some questions. The exam workshop, I'm hoping to run it in February again. The platform is getting too busy, so yeah, I do what I can, but limited resources. It's not always easy. AA is asking Red Hat Console. Yeah, Red Hat Console is now scheduled for, or will be scheduled for February. You cannot see that in the agenda yet, but it will be there. The problem is that the platform is too busy, so sometimes it takes a little bit of time. Right, folks, I would like to show you a solution for this lab. Create a shared group directory, structured data profs and data student that meets the following conditions. I'm going to run the commands, even if on my system it's not strictly necessary, but that allows you to verify your work. So mkdir -p data students and /data profs. You did know that one mkdir can create multiple directories, didn't you? Now, the next part is members of the groups have full read and write access to their directories and others have no permissions at all. Now, I got feedback. You're not saying what to set the group membership to. Yes, that's right. But if you read the question, there can only be one solution. You will need to think beyond the question every now and then. And when a question says members of the group have full read and write access to their directories, well, that suggests that we have a profs group, we have a students group. So obviously you need to make these owner of their directories. So chdrp students on data students and chdrp profs on data profs. Then the question is, that the members of the group have full read and write access to the directories and others have no permissions at all. And SJ, I do understand French, and I don't know. Je comprends pas pourquoi tu postes des messages en français, mais préférablement mettez en anglais, c'est plus clair pour tout le monde. Sorry, folks, I get a question in French and I'm answering in French. You need to read beyond the question. That's the point that I'm making here. And we need to set permissions. And how are we going to set permissions? ls-l on data profs is showing me what? Oops, is showing me the wrong thing. I didn't want to do that. I wanted to set the permissions the right way. So what is the right way? Well, members of the groups have full read and write access to their directories. That's a 7 for the group. Others has no permissions at all. That's a 0 for others. And nobody is talking about the user owner. Well, if nobody is talking about the user owner, I would say leave the user owner alone. Meaning, don't change anything for the user owner. Both of these directories are owned by user root, and that's okay. Permissions don't really matter for user root anyway, but it's inconvenient if you take all of them away, so I wouldn't do that, and I would just go for chmod 770 on star. And that's what I had in mind for this lab. How about set group ID and sticky bit? I don't see anything in the question that refers to set group ID and sticky bit. So this is what it's supposed to be. And that's all for now. I'm going to make a start talking about partitions. And I think I will just do that demo mode. There is one little thing, and that is if I use LSBLK is showing my current block devices. And oh boy, I have NVMe 0 and 1. Yeah, that is if you are using VMware Fusion and you install Red Hat in VMware Fusion, it's giving you an NVMe 0 and 1 device. That's an NVMe device. NVMe, let's call it SSD on steroids. And well, that's my primary device, so I'm just going to work with it. I hate it because SDA and SDB is easier, but I didn't think about as well installing the virtual machine. And hey, I want you to be flexible with these device names anyway. So what do I need? Well, I need to check my current usage. I have a 20 gigabyte disk device. On the disk, I have two partitions, and the partitions are taking up 1 gigabyte and 19 gigabytes, so I don't have any unpartitioned disk space. And that's what I'm going to change. And in virtualization, there's an easy way of changing it. I'm powering it off. I'm going to the virtualization software. That's the properties of my virtual machine. You don't see it, but it's not really that important. I'm increasing the size of my primary disk, and I'm going to add a secondary disk so that we have something to create partitions on. And I would say do the same so that you have the appropriate devices as well. I'm booting. Here we go. And you should be able to see my system booting again. Blinking cursor in the upper left corner, that stays there for a little bit. Should not be too long. So let's be patient. Oh, I didn't shut down my mail client. I did not, but okay, no problem, SJ. And let me open my terminal again. Resize it a little bit. And let me do LSBLK. What is LSBLK showing? Well, LSBLK, like before, is showing my block devices. And in the list of block devices, I am seeing NVMe 0 and 1, which is now 30 gigabytes. I'm also seeing NVMe 0 and 2, which is a complete new disk device. And for now, I'm just going to use NVMe 0 and 1 to create my partitions. How do we create partitions? Well, this is one topic where I don't agree with the way how Red Hat is teaching it. If you go to the Red Hat course, they tell you about the parted utility. I don't like the parted utility because it's not very powerful. So I'm so sorry, folks. I'm not going to show you the parted utility. I am going to show you the most powerful universal utility for managing storage devices, and that would be fdisk. So I'm using fdisk on dev NVMe 0 and 1. Hey, before I continue, one more thing about the name of the device. You might be used to working with SDA for the primary disk device and SDB for the secondary disk device and so on. And that is something that you shouldn't be doing. Because these devices depend on the driver that you are using, on the disk type that you are using, and if you are working with Linux, you can see any disk device. So if you want to work with partitions and what so on, start by using LSBLK to discover your disk devices, and then pick the disk device that you want to have. So I have NVMe 0 and 1, that's my hard disk, so that's equivalent to SDA or maybe even VDA. I need to mention VDA in case you are working with disks in a KVM virtual machine. Your primary disk would be VDA, your second disk would be VDB. MD is asking, my deployment is XFS, but I have another empty disk. How should I partition it that it would end up as LVM? MD, you need to wait until tomorrow. Tomorrow I will tell you everything you need to know about LVM. Today I'm not going to talk about LVM at all, because you are never going to understand LVM if you don't understand traditional partitions. This is about traditional partitions. So FDisk is what I'm going to use. And oh boy, I'm getting a warning in red. We should take warnings in red seriously, shouldn't we? And what is it telling us? It's telling us that repartitioning is probably a bad idea. It is recommended, blah, blah, blah. Yeah, right. This is for people that don't know what they are doing. And let's face it, if you are doing the wrong thing using FDisk, you may destroy all your data. And if you're destroying all your data, there's no way back. So this is how they are trying to warn you. Of course, I'm going to ignore it. I'm going to continue anyway. In FDisk, they have the most stupid option for getting help. Type M for help. I rather see this as type M for menu, because here you see all the commands that are available. And what we need is the generic commands to add a new partition, to print the partition table to start with. So let me do P. P is printing the partition table. And there we see the partitions currently existing. So I have NVMe 0 N1 P1 and I have NVMe 0 N1 P2. So on an NVMe disk, your partitions are named P1, disk device name P1, disk device name P2, etc. On an SDA disk, you would get SDA1 and SDA2 and SDA3. And in case you are wondering, why don't they do that on an NVMe disk? Well, that's because the NVMe device name by itself ends in a number. And NVMe 0 N11 wouldn't be very obvious, particularly not if you are going to create 126 partitions. NVMe 0 N1126, that wouldn't be obvious at all. And that's why in NVMe they create your partitions with names P1 and P2 and P3, etc. Good. What we also see is that we have a 30 gigabyte disk at this point. And we have currently 20 gigabyte in use. I increased the size of my NVMe device. And because I did, I can now start creating additional partitions. So I'm using N for new partition. Now we see what happens on a classic disk device. Now when we talk about storage, there are two ways to organize your disk. The old way and the new way. The old way is MBR. MBR is a part of the 1981 PC specification. Oh my goodness, it's 42 years old. So the 1981 PC specification, that was a specification that was created in the early days of the personal computer, where 5 megabytes disk were really very big. And all partition information needed to be stored in a master boot record, which was only 512 bytes, and you only had 64 bytes for partitions. In 64 bytes, you could create 4 partitions. And that's what we still have in MBR partitions that apparently we are using here. So it's asking for primary and extended. What is the idea? You can create 4 primary partitions. Once you've created 4 primary partitions, the 64 bytes that is reserved for your partition table is completely used. You can't add anything anymore. So what we are now going to do now, well, I am going to create a new primary partition because by any means I still have 2 free, and that's okay. So I need to start thinking by the time I'm creating my 4th partition. But for now, I'm okay. I'm creating my primary partition. I'm using N. That's stupid. I need P for primary. And then it's asking the number, well, partition number 3 and the first sector. I'm accepting the default sector. These sectors are listed in bytes. That's just because of the way our hard disk is organized. So sectors listed in bytes, that's okay. Last sector, I am going to specify the desired size using plus number followed by a K, an M, a G, a T, or a P. I want to add a 1 gigabyte partition, so plus 1 G is what I need to do. And there we go, and we see that it created a new partition of type Linux and a size 1 gigabyte. If that is true, I need to be able to confirm that using P for print, and yeah, I can see that we have partition number 3, and I'm happy with it. And in case you don't know what is going on, feel free to use M for your help. But I do know what is going on, so I'm using W to write. This is writing the partition table to disk. And in order to verify that this really happened all right, I would say use lsblk, list block device. And lsblk is showing NVMe 0 and 1p3 existing on disk right now. That is what I needed. Now, on some operating systems, if you create a new partition, you can start using it immediately. That's not the case on Linux, because a partition is just a reservation of space on your disk. If you want to start doing something with it, then you need to create a file system on top of it. And that's what we are going to do next. So if I want to start storing files on my partition, I need to create a file system, and that will be mkfs. For now, I only want to talk about the default file system on Red Hat, so I'm making that mkfs.xfs on /dev/nvme NVMe 0 and 1p3, and that has formatted the XFS file system. And now I can start using it. And what do we need if we want to use the partition? We need to connect it to a directory. We need to mount it. You've probably seen the mount command before. I'm using mount dev NVMe 0 and 1p3 on a temporary directory /mnt. That's good enough for me. I'm going to mount it on /mnt. And next, I want to verify, and I'm using lsblk, and lsblk is showing that NVMe 0 and 1p3 is now mounted on /mnt. GC is asking, after fdisk, it's not required to run udev adm saddle. GC, that's a comment that was for the early days of systemd, but nowadays that is really not required anymore. So just create your partition, it will be picked up automatically. In RHEL 9, that procedure is working perfectly, so no need to do anything complex here. Okay, I want to pick it up. I just mounted my partition manually. Do you think it automatically comes back after a restart? Well, I can tell you, on Linux, if you don't put it in a configuration file, it will never come back automatically after a restart. So we need to put it in a configuration file. And RM, there's no need to run partprobe. Partprobe was a useful command in RHEL 7, but partitioning has become so much more mature in RHEL 9, so partprobe is not a relevant command anymore. I never ever used partprobe on RHEL 9. to be honest. And also on rel 8, I pretty rarely have used the part probe utility. What I do need to do, I need to put it in etc fs step. So in etc fs step, we are going to make mounts persistent. How do we do that? By filling in this line that contains 6 different columns. Dev, not SDA, NVMe 0 N1 P3, that's the name of the device, followed by the name of the mount point. I'm going to mount it on my files, followed by the name of the file system, which is XFS. And next, I am going to use defaults in 0 and 0. I'll tell you about defaults in 0 and 0 later. For now, I don't want to be talking about them. I just want to put it in etc fs step. And in etc fs step, I'm going to save my changes. And now it is going to happen automatically. How can we find out? Well, you could find it out by rebooting. But I would say use mount -A. Mount -A is trying to mount everything that is in etc fs step, which is not currently mounting. And the nice thing about mount -A is if there is an error, it will tell you about it. My mount point doesn't exist. Does that make sense? Yes, because I need to create the directory mkdir / my files, and now I'm doing mount -A again. And oh boy, NVMe N1 P3. I made a typo. I didn't even do it on purpose. I made a typo. It's not NVMe N1, it's NVMe 0 N1. I do hate the NVMe naming. And now I do my mount -A again, and now it's doing all right. Okay, 2 questions. OV is asking, how do we know the file system is XFS? mkfs.xfs dev NVMe 0. This is where we created it as XFS. I do like your answer as well, GC, lsblk -fs. Let me type that for you. lsblk -fs is showing file systems as well. It's not getting any more readable, but this is one way of doing it. And yeah, SJ, you are talking about clusters. Is it not needed when we create a Linux cluster to have the same major and minor number? Just a question. Well, this question, SJ, really doesn't belong in RHCSA. I'm sorry for it. And I think if I wanted to answer the question, the answer is no. But I have a hard time understanding what you mean when you say, is it not needed? The it, what exactly is the it? Good. TT is asking my opinion about Parted and if it's a good idea for quicker results on the exam. TT, if you learn FDisk, you never want to use anything else anymore. Parted is making advanced options, some of which are required to pass your RHCSA, less accessible. Parted, in my opinion, is slower, FDisk is faster. Of course, I'm taking a long time now to explain FDisk, but that's because I want to tell you about all of its gory details. FDisk rules and Parted is a confusing utility. Let me continue, because now we are at the point where I want to be. I just created the partition, and I am going to remount it. Okay, you're talking about UDEV ADM. No, not even in a cluster course, but SJ, I really shouldn't be talking about clusters here because it's off topic. SC, you're asking about PV create, LV create SC. As I already told, that's LVM. We do that tomorrow. Today is not about LVM. Today is about traditional partitions and not about LVM. TL, that one is also for tomorrow, the differences between MBR and GPT. For today, I want to continue and show you one more thing about master boot record. The problem is, folks, everything I'm showing you today is really irrelevant for the exam. And storage is complex, and that's why I'm telling you in 3 or was it even 4 different sessions about storage. Storage will come back all the time. So if you are missing stuff today, no worries about it. What I want to do today at the end of the class, I want to do one more demo that is all about MBR partitions. Let me get back to fdisk dev NVMe 0 and 1. That's the name of my disk. And I am going to use N for new. I want to create a new partition. It's telling me that I have 1 free. So in MBR, you only have space to create 4 partitions. Now, what do you do in MBR if you need to go beyond 4 partitions? That's what we need to talk about. Well, what you are going to do, you are going to create an extended partition. And in the extended partition, you are going to create logical partitions. Hey folks, terminology. Tomorrow we will be talking about logical volumes. A logical partition is not the same as a logical volume. Let that be clear. Today we are talking about logical partitions. So I am creating an extended partition. There we go. This is partition number 4. This is the last partition that I can create in my partition table. So I need to allocate all the remaining disk space to the extended partition. That's why I'm pressing enter and enter. And then I'm using P. And we can see that I have a partition number 4, which is an extended partition. But there is only one reason to create extended partitions. An extended partition is like a box in which you are going to create logical partitions. You're not putting a file system on the extended partition. You are putting the file system on the logical partition. So when I type N right now, it's prompting for a first sector. And if you look carefully, you can see this first sector falls within the range of an extended partition. I repeat, in an extended partition, you create logical partitions, and that's the only purpose. So I'm doing first sector and enter, and last sector, I'm making it the 2 gigabyte partition. And for the sake of what I want to show you and where I want to end today, I am creating another logical partition. So N for new and first sector, pressing enter, and last sector plus 1G. So now I'm using P, and I've partitioned P5 and P6. And I want to work with them, P5 and P6. I'm using W to write, and I'm going to use not mkdir. Yeah, let me do an mkdir part 5 and an mkdir part 6, because I want to mount them. And I'm going to format them mkfs.xfs of dev NVMe 0 and 1 P5. Yeah, PT, Red Hat wants you to use Parted. So obviously they tell you that Parted is better. I'm not paid by Red Hat, I'm independent, and really Parted is not as efficient as fdisk. End of discussion. I'm teaching fdisk in my class. Good, I'm continuing. What did I just do? I formatted P5 as XFS. I formatted P6 as ext4. And I am going to continue and make this persistent, etc fs step. And in etc fs step, I am going to add dev NVMe 0 N1 P5. mounting that on part 5, and then doing that as XFS defaults in 0 and 0. And then I'm adding dev and VME 0 N1P6. I really hate these names, but we'll talk about that more tomorrow. Mounting that on part 6 as ext4 with defaults in 0 and 0, and using mount -A. And that seems to be all right. Now, folks, pay attention to what I'm doing right now. For some silly reason, I decided that I want to get rid of partition number 5. Let's get rid of partition number 5. And I can warn you, I'm going to create some trouble. And that's exactly what I'm going to do. And that is where I'm going to pick it up tomorrow. Folks, you have many questions that I'm going to answer tomorrow. If you ask a question that I'm not answering specifically, then the default answer is, we'll cover that tomorrow. I have 6 minutes left, and I need to be efficient with my time. I'm going to delete partition number 5. So I'm using fdisk on dev and VME 0 and 1, and I'm going to delete partition number 5. W to write, and oh, it's telling me kernel still uses old partition table, new table will be used at next reboot. Okay, I need to reboot. This is unavoidable. If your system is telling you it needs to reboot, then, well, guess what? It needs to reboot. Next, I'm using Vim on etc fstep, and I am going to make sure that my partition number 5 is no longer mounted. JD, partition number 5 was a logical partition inside the extended partition. Now I'm going to reboot. There goes my system. It is rebooting. When I see the turning wheel, I can press the escape key, and I can tell you that is what I want to do, because what do we see? We see that the boot procedure is getting stuck. It doesn't work anymore. I am in trouble. What is going on? Well, I can tell you, because I removed partition number 5, the partition previously known as partition number 6 has changed its name. So the old partition 6 has become partition number 5. In etc fstep, I'm trying to mount partition number 6. Doesn't exist anymore. That's a critical situation, and that is why my system doesn't work anymore. And guess what? Tomorrow, we are going to fix it. So, that's all for today. Normally at the end of day of class, I'm providing a pastebin with my command history. I will do that later today or tomorrow. And you can access it on pastebin.com/u/Sander van Vught. JP, small correction, you can have one and only one extended partition. The rest of it is primary. This troubleshooting mode, that's where we are getting back tomorrow. Folks, one thing. I am very aware that this last demo included a lot of stuff that you think might be complicated. No worries about it. Tomorrow, first hour, I will take about an hour to go into more detail about everything we have done here in the last 20 minutes or so. So if you feel you don't fully understand, it's okay. We are picking it up tomorrow. No worries about it. And tomorrow we will do a little bit of troubleshooting as well, because hey, we want to make it working, isn't it? So everybody, thank you very much for attending today's session. And I'm looking forward to continuing this session tomorrow. Take care, everybody, and see you tomorrow. Bye-bye. I'm out of here.
All right. And thank you, Sander, for sharing your knowledge with us for day one. Thank you all for attending. I do want to remind you the course was recorded. You will receive that recording within 24 to 48 hours. With that, we will wrap up day one of the course, and we look forward to having you join us tomorrow for day two. Have a great day. Take care. Bye-bye. All right.